In today's session, we're going to continue on the concept of synchronous management. Today, we're going to talk about principle number 9, which is understanding the level of utilization of non-bottleneck resources. And what's that relationship to the constraints of the system? If we look at any system, we know that there can only be one constraint. So in this case, we have one constraint, which is internal constraint at this resource. And if we understand the utilization of that resource, just to say this is at 90%, then what should the utilization of the other resources be to create balanced flow? We have this resource, the throughput of the system is determined by this resource. If we release more work into the system to try to keep high utilization on these non-bottleneck resources, what happens is we build excess inventory, which creates overproduction, which is one of the wastes of lean. So we don't want to create waste of the system by trying to keep high utilization everywhere. And if we look at the reliable production lead time, we only want to release enough work into the system within the reliable production lead time to keep the utilization of our capacity constraint resource extremely high. And if we have the internal constraint, that means we have more market demand than we have capacity. So the utilization of this resource is extremely important. So now let's understand the effect on the rest of the system based on this resource's utilization. So first, let's understand what are the measurements that most companies use. The first measurement we see is utilization. So what is utilization? So utilization is the actual time the process is operating, producing value-added work relative to its available time. So if we have 10 hours of shift time available, how many hours is it actually producing over that 10 hours, or actually cycling or producing value-added work? So if we're working 8 of those 10 hours, then our utilization's 80%. But of course, most organizations want high utilization everywhere, so what they do is they increase the batch size or the order size to allow for larger production runs. Next is efficiency. So what is efficiency? So efficiency looks at the actual output against some standard. It's usually measured in units of time. So of course, if I have a resource that the expected output is 100 units per hour, and if the first hour I measure their output and they got 90 units in that first hour against the standard of 100, my efficiency is 90%. And of course, most people are trying to drive high efficiency everywhere because we need to generate more standard direct labor hours, inventory credit, earned hours, machine hours, whatever the measurement is we're trying to maximize. So if we take the utilization and efficiency, then we can take and determine our overall equipment effectiveness by taking the utilization times the efficiency, and then we add in our quality piece of our first pass quality. So our OEE then takes our utilization of how many hours it's actually producing against its available time, what's the efficiency of that, how many units it actually produce against the standard, and then how many of those were good first pass quality, and that becomes our overall equipment effectiveness. If we have a system where we have balanced flow, what does that mean? So we restrict the release of work into the system based on what the capacity constraint of the system can produce. So if we look at the capacity constraints utilization, in this case, we have 90% utilization on our constraint. What is the utilization of the non-bottleneck resources? Of course, we don't want it 90% because we're unbalanced to create that balanced flow. So let's look at our protective capacity. So we have 25% protective capacity. That means we got 25% more capacity on operation 1 than we do operation 4. Operator 2 has 20%. Operator 3, 40%, Operator 5, 10%, Operator 6, 50%, Operator 7, 30%. So how do we determine what the utilization of those non-bottleneck resources should be? So in this case, we take the utilization of our capacity constraint resource, divide by the capacity that we have available on our resource number 1 here, which is 125%. And so the maximum utilization I can expect off of Operator 1 to keep balanced flow is 72%. Also, if we look at this other operator that has 50% extra capacity, so I take the utilization of our capacity constraint resource divided by that 150% capacity, the best I can expect is 60% utilization on this resource. So in an unbalanced system where we have balanced flow, we can't expect the utilization of our non-constraint resources to be any higher than our capacity constraint resource. Most cases it's going to be lower or much lower. So if we look at a balanced flow system, we need an unbalanced capacity in order to achieve balanced flow when we have dependencies and variation. Measuring the effectiveness of the system can be measured by understanding the OEE of the constraint. So if we measure OEE any place, we measure it on the constraint. The availability of non-constraints is reduced by the amount of protective capacity of the non-constraints. So we want that utilization of our non-constraints to be less to get balanced flow. So therefore, the goal is not to maximize OEE on all the non-constraints. The goal is to maximize the OEE on the constraint and then reduce the capacity on our non-constraints to be in line with the constraint to create balanced flow. So that's our session for today. Next week's session, we're going to talk about principle number 10 on understanding the difference between utilizing resources and activating resources.